Hello, I'm Patty Simpson with Simpson Math. Today we're going to complete our percent application exercise. And today I'm going to show you the other two application exercises that you're going to have due this week. And the first one I want to look at is the data collection application exercise. This is nice and simple. It's not too difficult. Shouldn't be that time consuming. But we need this data so that we can use it for the rest of the semester. So we're gonna y'all are gonna collect data, get to see what that's like. You're gonna record the data. You're gonna turn it in. I'm gonna take all of our data and compile it. And I'm actually going to use this class's and the next class's data. We're going to compile it all. And then the rest of the semester, we're going to use it to organize it, analyze it, do all those things with the data that you might do if you were a statistician. So, here's what you're going to do. You're going to survey exactly 5 adults from your extended family. And you're going to ask these 2 questions. So you need to find 5 adults to ask these 2 questions. How many hours per week do you typically work for pay? So you're going to tell me their answers in here. And then, have you received at least 1 dose of the COVID-19 vaccine? And you're going to put their answers in here. So just ask 5 people, and we're going to collect that data. Then, once you've collected that data, you're going to write me a summary telling me a little bit about what you did. So, in your summary, you're going to write me, again, I'm trying to get y'all where we can communicate our ideas here in this statistical environment. So we've got to be able to write a little bit. I know it seems like English. It is a little bit. So, my explanation here is you're going to write me 4 different paragraphs. In the first paragraph, you're just going to write an introduction explaining what you're doing in this assignment. You know, I collected data from 5 people in my family, and I asked them 2 questions. Now you're going to do that first. Then you're going to write a second paragraph, and in the paragraph, again, you're not going to use numbers. You're not going to put 1 and put your answer. You're not going to put 2 and put your answer. You're going to write it as a paragraph. And in that paragraph, you're going to tell me, you're going to answer or include this information in there. It says your sample is the adults in your extended family that you gathered data from. Give your definition of an adult and your definition of extended family. It needs to say, and your definition of extended family. I needed to edit. Then, number 2, discuss your sampling procedures. Think about the sampling methods that we've learned about. You know, the ones that you're doing in the Gettysburg Address application exercise. Think about those different ones. Which sampling method did you use? And explain to me how you know that that's the sampling method you used. Okay. Then, in your third paragraph, you're going to tell me about the variables that we have collected data on, identify them, and then describe them. Remember, with the description, there's 3 parts: qualitative, quantitative, continuous, discrete, and neither, and the level of measurement. And you may have more than 1 variable depending on the question. So look at the questions, identify your variables. And then in paragraph 4, I want you just to summarize what we did, what you noticed from your data. You know, I noticed that the people that I interviewed work a whole lot, or people that I interviewed, they don't work anything. I noticed that, you know, half of my people got vaccines and half of them didn't. Whatever it is you noticed. So conclude your paper with that summary and what you noticed from your data. And then you're going to submit it into Dropbox. Make sure you get your table with the data, and then write me that summary. Okay, so that's one application exercise we're going to do today. That's by Friday, you know, at 11:30 p.m. with the 24-hour grace period. So really by Saturday, 11:30 p.m. Okay, so that's one of them. Then the other one we're going to do is a percent application exercise. So we've been looking at percentages, we've been using percentages a little, and I just want to look to see, here it is here, percent application exercise. This would be a good day to come to class. Okay, so this is the percent application exercise you're going to do today, and I'm going to do an example of this in class to help you out. All right, here's what it looks like. You're going to have to go to this website, and we're going to look at some data that's out there about COVID, and we're going to analyze that data. We're going to find out some different percentages by looking at the data on this website. So, maybe it's just easier for me to do the thing, but anyway, that's what you're going to do. You're going to go to the website, and we're going to analyze some information off of there. So there's going to be a map I'm going to show you here in a second. You're going to be looking at these counties on the map: Bell County, Dallas County, Dimmitt County, Harris County, and Travis County. And it's going to give us some information about how many cases there have been in the last 2 weeks in each of those counties. And we're going to find it, but here is the example. Williamson County, it said, I used Williamson as an example. The new cases per 1,000 in the last 2 weeks were 9. So I wrote down the 9. Okay. Then, so we're going to, we're just going to find out how many new cases there were in the last week. Then we're going to find out what percent of the population was infected in the last 14 days. So, what percent of their population, of their, people in that county were actually infected in the last 14 days. And then we're going to find out, from that, you're going to use that information to find out the population of the county. You're not going to go to Google to find out the population of the county. We're going to use their numbers to find out the population of the county. And then we're going to find out about the total number of confirmed cases, how many were in the last 14 days, and we're going to find out the percent that are new cases. Out of the total cases, how many of them are new cases within the last 2 weeks? Then we're going to look at the deaths, and we're going to see what percent of deaths are there per cases. How many people, once they die, what percent of those that get COVID die? And then you're going to have to analyze the counties. You're going to look at your data and you're going to analyze them. And you're going to decide which area right now is in the best shape, which one's in the worst shape. You're going to do some ranking. Okay, so let me do an example of this. And the first thing I'm going to do is go to this website. On this website, they've been tracking COVID from the very beginning, and we've got all kinds of information on here. So you can scroll down, and we can find out, all kinds of information, but the one you're going to need is the yellow map. So they've got lots of different graphs, lots of different data that we can look at. But what we're interested in, there's vaccinated by county, and we want to know, so scroll way down to the yellow map, there it is. We're looking at new confirmed and probable cases reported in the last 2 weeks. At this map is the one we're looking at. And it has, each one of these little squares is a county in Texas. So the counties you're going to be looking at are Dallas County, is up near Dallas. So when I scroll over it, see how it says Dallas County? So that's how you know you're in the right county. And then those are the numbers we'll be looking at from Dallas County. You're going to be looking at Bell County, that's where we live. So, go to Austin, go up a little bit. There's Bell County. That's where Temple is, so we're north of Austin. That's one of the ones you'll need to look at. Then there's Travis County. Travis County is where Austin is. So here's Travis County. And then Harris County is where Houston is. So you go over to Houston. There's Harris County. And then Dimmitt County is down here somewhere. North of Laredo is what it says. So we're gonna go down south. Here's Laredo, go north. And that one right there is Dimmitt. So those are the ones that you're gonna be looking at over the next. Okay. So I'm going to, though, look at Somerville County. And I'm going to do an example of, I'm gonna pretend Somerville County was on the list, and I'm gonna do everything that you're gonna do for your counties, I'm gonna do with Somerville County. So, Somerville County is the second smallest county in the state. It's a tiny little county. There's not much there. Montrose is the major town. Maybe you've heard of Dinosaur Valley. They've got Dinosaur Valley there. They've got some cool dinosaur footsteps there. Cool. Okay, so I don't know where am I gonna do this. I need to look there, and yet I was gonna write on this paper. Alright, I guess I'll go back and forth. Okay, so. That might be annoying though. Maybe I'll write down everything off the site first. Let me go back to it. Let me do this first. I'm gonna write down everything off the site, and then I'll have it. And yeah. Alright, I'm just gonna write this down. Somerville County, new cases per 1,000 is 6.1. So it says new cases per 1,000 is 6.1. And then it says new cases last 14 days is 54. If I say it wrong, y'all let me know because my eyes are not. New cases last 14 days is 54. Total confirmed cases is 685. Total probable cases is 576. And total deaths is 17. Okay, that's really all I need that map for. Now that I have those numbers, I'm just gonna look at this piece of paper. So for each county, that's what you're gonna need, is that little box up there. Okay. So the first thing I'm gonna do is, your first little box you're gonna fill in is the cases per 1,000. First, you need to tell me what date you accessed it. Because each day it may change because it's looking at the last 2 weeks. So you need to tell me first what day you did it on. So if you're doing it today, then you're gonna write 9/1/21. But if you wait till Friday to do it, then you need to write Friday's date. Okay, then Somerville County, the cases per 1,000 is 6.1. What that means is for every 1,000 people in the county, for every 1,000 people in the county, 6.1 of them has gotten COVID. So for every 1,000 that there are, 6.1 of them has gotten COVID. then, in Somerville County, what percent of the population has been infected. This is in the last 2 weeks, by the way. That's in the last 2 weeks. So I want to know what percent of the population was infected in the last 2 weeks, in the last 14 days. So, tell me again, what is a percent? A proportion out of 100, a fraction out of 100. So I need a fraction to deal with, and then I need to be able to turn that denominator into 100, or get it out of hundreds. So what's my fraction here? 6.1. That's exactly it. Here's the fraction, 6.1 over 1,000. 6.1 over 1,000. Now, what do I need the denominator to be? 100. So I need this denominator to be 100. How am I going to get down to that 100? Divide by 10. In order to get rid of one of those zeros, I divide by 10. So I'm just taking my 1,000 and dividing it by 10. What is 6.1 divided by 10? Yeah, is it going to get bigger or is it going to get smaller when I divide? Smaller. Okay, then I'm dividing by 10, so we're just going to move that decimal over one spot. That's what happens when we divide by 10. The decimal gets moved over one spot. And since we're making it smaller, it needs to be moved over to the left. So that's going to be equal to 0.61. So what percent of the population was infected in the last 14 days?
0.61.
Yeah, 0.61. 0.61%. Not even a full 1%. So while it's 6 out of 1,000 people, it's not even 1 out of 100. If you get a group of 100 people together in Somerville County, there might not be a single person in there. Well, that's not quite how that works anyway. But you would expect 0.61, half of a person, a little more than half of a person, to have had COVID in the last 14 days. We're only talking about the last 14 days. Okay. So that's part 1. Or task 3, actually. We've already made it to task 3. Now we're going to do task 4. In task 4, we're going to use the data from the site to fill in these columns, and then we're going to calculate this last thing. So first we need to know the new cases in the last 14 days. Well, we said that was 54. I'm going to put that 54 in there. By the way, on this one, you can check yourself. You could check yourself by taking 6.1 and dividing by 1,000. That didn't work. 6.1 and dividing by 1,000. That 6 is not showing up exactly, but that's a 6. So go out to the hundreds place for percent And sure enough, it's 0.61%. Remember, on application exercises, you can use a calculator. We're dealing with real world numbers. Okay, so back to this. In the last 14 days, we have 54 cases. We want to know the percent of the population infected in the last 14 days. Oh, we did this. The percent was 0.61. And now I want to know the population of the county. So if I know that 0.61% of the population is how much got it, how many have gotten it, what percent has gotten it, and I know 54 have gotten it in the last 14 days, I should be able to figure out their population. So they've had 54 cases in the last 14 days in Somerville County. How many people live in Somerville County? Is that a big number or a small number? I mean, if the county's only made up of 54 people, that would be a lot of people. But if the county's made up of 3 million, well, 54 people is not all that much, right? Okay, so how can we find out then the population?
Can you do something with the 1,000 and the 6.1?
Oh, we might could do that where we say, well, 0.61 out of 1,000 is equal to, I need it to be 54 out of how many total? I might could do it that way. So Diamond says, one way to do it is to take the 0.61 out of 1,000. We want the total population. Well, if we know that 0.61 out of 1,000 gets it, and 54 have gotten it, then maybe we can find out that entire population. There's definitely one way to do it. And then solve it that way. Here's another way to think of it. If I want to find out the total number of cases, if I know the population, and I know the percent of people that got the cases, then the total population times that percent would give me the number of cases. Right? If I know the population and I know the percent of those infected, I can find out the number of cases. So this is just another way to do it, to say, look, oh wait, this was wrong. This is not 0.61, this is 6.1, right?
Yeah.
Sorry. No, 6.1, not 0.61, because it was out of 1,000. So here, I don't know my population, that's what I'm looking for. But I do know my percent is 0.61%, and I do know the number of cases is 54. Of course, if I'm going to deal with this percent, I need to change it into either a fraction or a decimal. So maybe we make it a decimal, 0.0061, that's the same as that. How would we solve for our population if I'm multiplying here and there, what would I need to do to both sides of my equation to get population? Good, because the inverse of multiplication is division. I'm gonna divide by both sides. Those guys become 1, leave me with my population. Because this is an application exercise, I can take 54 and divide it by 0.0061. This calculator absolutely sucks. Sorry, I was aiming for the trash can. Almost got it. Almost got it. Almost got it. Sorry. I didn't mean to cause cardiac arrest over there. Let's try another one. 54 divided by 0.0061. So there's about 8,852 people. 8,852 people. Somewhere around there. In Somervell County. I told you it was the second smallest one in the state, so it shouldn't be all that big. I'm gonna do it Diamond's way, just for funsies. So Diamond said 6.1 over 1,000 needs to be equal to 54 over our population. Let's make sure we get the same answer. Diamond, what would you do now?
Why are you calling me out like
It was a good idea, it was a good way to do it.
I was just trying to think of something, I honestly don't know where I would go with it.
Okay, y'all know if you have a proportion like this, how to solve for that x? Yeah, you multiply both sides by 100, and then multiplying both sides by that 1,000. That makes that disappear, or become 1, that becomes 1. I'm left with 6.1, and I multiply 54 times that 1,000, which gives me 54,000. Over x, thank you, I lost my x there for a minute. Now I'm gonna multiply both sides by x. Which makes that become 1, so it leaves me with 6.1 x.
Then don't you have to divide it?
Oh yeah, and then I'm gonna divide it by 6.1. Let's just make sure we get the same answer. 54, 1, 2, 3, divided by 6.1. Look, I got the same thing, 8,852.
Finally, that was so complicated for no reason. Well, actually, that's a lie, because I didn't know how to do it.
I know a lot of people set theirs up as a proportion though, so if you set yours up as a proportion, this is how you would solve that. But another way to do it is just to say, look, I know that if I had my whole population, I would multiply by the percent of those infected, and that would give me my number of cases. So now I'm just gonna fill in with what I got. Okay, so I know in Somervell County, there's about 8,852 people. I bet if I went to Google, it would be somewhere close to that, but Google was not always like accurate enough to date. And we wanna use their numbers, trying to find out their numbers. Now what? What are we doing next? Oh, let me add that. So there's about 8,852 people. Round it up or down-ish. Is that a person, 0.45? How can a population be a point? Okay, Now we're gonna use the data from the site, because we're rounding somewhere, they're rounded at some point, that's the reason we end up with half a person. So we're rounding it up. Use the data from the site to fill in columns 1 and 2, and then use 1 and 2 to compute 3. So we look at the site, we go, how many cases were in the last 14 days? Well, we know it was 54. How many total confirmed cases were there?
685.
685? Now with the percent of total cases that are new cases.
50. Put the 54 over the 685.
Perfect. So here I am doing task 5. When y'all are doing your work, be sure to show me your work. And I'm doing Somerville County. So you know, you're gonna turn in this paper, but you also need to show me your work along the way. So I'm doing Somerville County, and I like that to find a percent. It's just a fraction. Out of 100, I mean, we could simplify this fraction, but maybe there's an easier way to do it.
Well, look at me. I take the long route and I simplify from there.
We could totally simplify, but since I'm letting y'all use some fancy tool.
Just go ahead and divide it.
Oh yeah, we could just divide. How about we just divide it? I mean, we could kind of get an idea. To get down to 100, I would need to divide by like, well, this is almost 700. Y'all agree with that? That's almost 700? So if I were estimating, let's say that I was sitting in that meeting with all those doctors and I need to estimate in my head about what percent this is. I would take this and I would say, well, that's about 700. So I need to divide by 7 to get down to 100. So I divide this by 7, it doesn't go in there pretty, but it's about 8. 7 goes in there about 8 times, 7 times, somewhere in between 7 and 8. So I would say, well, it's about between 7 and 8%. It's about, you know, somewhere in between 7 and 8%. Yeah. It's gonna be somewhere in between 7 and 8%. Let's just see if it really is between 7 and 8%. So I'm gonna take my 54 divided by, no I'm not, I'm gonna take my 54 divided by 685.
Oh, ooh.
Remember, you're going out to your hundreds place. 7.8%. Isn't that what we said it was? So we can estimate it knowing that you need to get this denominator down to 100. You can start doing some estimation. You can say, well, that's about 700. So divide the top and the bottom by 7. It's about 8%, almost 8%, not quite. And we estimated that. So this is, you know, rounded somewhere. It's 7.88%. This rounding business is why we end up with half a person as part of our population. So there's my work, but I'm going to go back to my chart. Notice that this was equal to, this was 0.0788321, but then I turned it into a percent by moving that, looking out to the hundreds place. So 7.8%. Be sure and put percent signs when you mean it, and not percent signs when you don't mean it. Okay, last one. So 7.88% of their cases have happened within the last 14 days. know if that's big or not, you know. Depends on the rest of the, what am I comparing that to? Does that sound like a lot? I need to know a little more in order to know if that's a big percentage or not. Now, we're gonna use the data from the map to fill in 1 and 2, then we're gonna use these two to compute 3 and 4. So now we're gonna look at the number of deaths. So how many deaths were there in the last 2 weeks? 17 in the last 2 weeks?
Yeah.
Or 17 total?
Oh, that's total, excuse me.
Yeah, that's total.
Does it say in the last 2 weeks?
Didn't write that one down, if they had it.
Oh, then they must not have.
No, they didn't have it.
Okay, so I need to fix this. This is not the last 2 weeks then. That's the problem with this assignment, is it's ever changing. That map is ever changing. So I make up the assignment and then they change the map. So this is just the total number of deaths. I was thinking, man, 17 in the last 2 weeks is a lot of people to die. So this is total number of deaths. Now I want to know the total number of cases. Yeah, let's stick with the confirmed cases. So how many confirmed cases are there?
685.
685. We could do it with both. We could do it with the confirmed cases, and then we could do it with the probable and the confirmed combined and just see the difference between it. So then the fraction of deaths per cases, how do I make that fraction of deaths per cases?
17 over 685.
Beautiful, that's all it is, 17 over 685. Don't make it complicated. This is your numerator, that's your denominator. So out of the 685 people that got COVID, 17 of them passed. Now, what percent of deaths are there per case? Yeah, how do I find out that percent? Good, I'm just gonna divide that. Again, I could estimate without having to use a calculator, so I can kind of check my work. I say this is about 700, so I need to divide by 7. 7 goes in there a little more than 2 times. So it's gonna be like 2.5-ish, something like that. Then I do my division. I go 17 divided by 685. And sure enough, move it over 2 decimal spots and it's 2.48. So again, what I'm doing, let me show my work. Task 6, Somerville County. I'm taking that 17 over 685. I'm dividing it, I get 0.024817, which is 2.48-ish%. What did it say about the probable cases? Total probable, total confirmed?
576.
Yeah, so I wonder, these probable, I guess we can just add those together to find out the total number that we think might have added in Somerville County. I don't know, this is a little, what does that mean? 6 plus 5 is 11, carry 1, 15, 16, carry 1, 11, 12. So maybe there's actually been more like 1,200 cases.
What if those are different numbers though?
Yeah, I don't really know what that means exactly.
What if they're like the same cases, it's just.
Yeah, what if some of these probable ones became, no, I feel like they would have moved them.
They move them.
Yeah, I bet they move them over.
The probables are the ones that like, where you've been exposed and we've tracked this person to there
And now you have symptoms so that you have
but
probable.
we don't know because you won't go to the hospital and you won't get tested, so.
Or maybe you even took a rapid test and it's not a good enough test. I don't know I don't know enough. I need to read what it means by probable. So when that happens and they're giving me some sort of data and I'm like, what does that mean? What does it mean to be probable? Does that mean that you were around somebody and now you've got 102 fever and you can't smell anything and so you think you have COVID but you don't ever go to the hospital? Somehow or another we still know that you have it though? I don't know. What does that mean to be probable? Defining things in stats is really important. What does it mean to be an adult? Who is it that you're gonna collect data from? Who is your immediate family? Or extended family, sorry, your extended family. So, what does that mean? Some of you may ask people at work and go, well, they're my extended family, I'm around them every day. If that's who you consider your extended family, we need to know that. Our population has changed. Or who is it that we're getting that information from? What does it mean to be probable? So if we did that, then all of a sudden that would be our denominator. 1261, how does that change things? Well, let's look. I'm gonna have 17 over 1261. Y'all just use the confirmed cases. We'll just stick with confirmed cases for yours. But this is a fun little exercise. What would I divide by this time? To get down to 100, about 13. That's about 1300. So I'm dividing either by 12 or 13, one of those. How many times does 12 or 13 go into 17? Just once and a little bit more. So it's going to be about 1%, 1.5%, something like that. 1 point something percent. Now when I put it in the calculator, let's see if it really is. 17 divided by 12, so that's 61. Sure enough, it's 1.3%. Look at y'all doing it in your head. Pretty impressive. 1.35-ish%. So if you count all of the cases, about 1% of them, one and a little bit percent of them died from the cases. So then you have to decide, is that a big number? Is that a little number? How worrisome is this disease if 1% of the people who are getting the disease die? And only not even 1% of the population has gotten the disease in the last 2 weeks, and then 1% of those are gonna be the ones that die, so how bad is this disease? So if it's your mother that dies, then all of a sudden you might be, oh, it's really bad. But you don't know anybody, then you're like, well, it's not all that bad. It's all relative, right? It's that whole, is $1 a raise a lot of money or not? If you find $100 bill on the ground, is that a big deal?
Yeah.
Oh, what if you're Bill Gates? If you find $100 on the ground, do you think that's a big deal? Kind of depends on your situation. If you find $1 on the ground, is $1 a big deal?
Absolutely.
If you're wandering around Temple and you're homeless, is that $1 a big deal?
Yes.
So it's all relative, right? It all depends. So numbers are kind of that way. $1 is maybe different to one person than it is the next. In one situation, $1 is different than $1 in another situation. And these percentages are the same way. What does that percentage mean? Well, we're going to compare some different percentages, and that's what you're going to do in this exercise. So you're going to look at that map, and you're going to compare different counties and just see how are these different counties faring. All right. Alright, so you have those two application exercises you're gonna do tonight, the percent application exercise and the data collection exercise.
Math made simple at Simpson Math. Thanks for watching.